Okay. We left off yesterday with one last example to finish in 11.4. And I know you have at least one, maybe two homework problems that do correlate with this. So I want to make sure and talk about it. We're looking at using a tree diagram. And there's different ways we can make tree diagrams. We're going to go based on the situation here. So read along with me. A school system compiled the following information from a survey sent to people who were juniors 10 years earlier. 85% of the students graduated from high school. Of the students who graduated from high school, 90% are happy with their present jobs. Of the students who did not graduate from high school, 60% are happy with their present jobs. What is the probability that a person from the junior class 10 years ago graduated from high school and is happy with their present job? Okay, so lots of information here. And again, I'm going to set up a tree diagram. Do you guys remember anything about tree diagrams? I mean, tree diagram, you have a starting point, and then it branches off, and then it branches off again. I don't know if that, rings any bells or not, but we are talking about the junior class from 10 years earlier, right? So I am making my juniors kind of to be my starting point. And we're going to start off by breaking that junior class up. How can we break that junior class up based on the information given? They either what or what?
Graduated.
Okay, they either graduated or I used NG for not graduated. Now, what was the percentage for graduated? That's the 85%. What's 85% as a decimal? 0.85. If 85% graduated, how many did not graduate? 15%. So that as a decimal is 0.15. Right? Okay. Now, with that in mind, we're going to go another step farther. The junior from 10 years earlier either graduated or didn't graduate. What about those graduates? What are the options after that?
Happy or not happy with their job.
Right. They are either happy with their job or not happy with their job. So we're going to take the graduates here, and we're going to break them up into happy, and I'm just going to use H, or not happy. I guess usually, kind of set that up back weird from what I normally do. It's been a bit. Okay, so either happy or not happy. What's the percentage for happy? 90%, right? 90% are happy, which as a decimal is going to be 0.90 or 0.9. If 90% are happy, what's the percent of non-happy? 10%. So non-happy, I'm going to use 0.10 or 0.1. Okay, those are the juniors that graduate. What about the juniors that did not graduate? What are the options for them? Well, they are either same thing. They are either happy with their present job or not happy with their present job. What are their percentages?
60.
Okay, 60% are happy. So that's going to be 0.6. How many are not happy then? Okay, so that means not happy is going to be 40%. Or in other words, 0.4. Okay, did we get all the information on there? Now, what is the question? What is the probability that a person from the junior class 10 years ago graduated from high school and is happy with their present job? So probability that they graduated and are happy with their present job. Now, generally speaking, you see the word and in probability, and what have I suggested?
Multiply.
That's going to be multiply, right? Now, when we look at this, we're going to look at the probability of graduating, and then we're going to multiply it by not just the probability of happy, because we have two different happy categories, don't we? So the probability that they are happy given, remember this from yesterday? Given that they graduated. Those are the two probabilities that we're going to multiply. What is the probability that a junior graduated? 0.85 times. What is the probability that they are happy with their present job given that they graduated? 0.9, because 90% of the graduates were happy with their current job. Okay, do the math. 0.85 times 0.9. Okay. 0.765. What if I ask you to give this to me as a percent, since the whole problem dealt with percents?
76.5%.
Okay, move that decimal over 2 places, and it is 76.5%. I'll be honest, I don't remember what the homework does. But I've shown you fractions, right? I've shown you decimals. I'm showing you a percent. I do feel like there was one you had to do a percent homework, so I'm just showing them to you. It was in decimal form in this one, you think? Okay, well, then you got the decimal form too. Okay, questions on that part of the example? If you can get the tree diagram set up, I feel like it's pretty easy to follow. And you might be able to do it without a tree diagram. I'm not saying you have to have the tree diagram to do it, and it just helps me organize the information and show it to you. The second part of this problem. What is the probability that a student from the junior class 10 years ago did not graduate and is happy with his or her present job? So what are we looking for? The probability of not graduating and, I can't spell and. I just use abbreviations and happy, N-G and H. Does that make sense? Yeah. Probability of not graduating and happy. I use those abbreviations up above, so. Now, what's that mean I'm going to do? I'm going to have to find the probability of not graduating, and then we're going to multiply it by the probability of what? Yeah. Happy given that they did not graduate. Okay. So what's the probability of not graduating? 0.15 times what's the probability of being happy given you were not a graduate? And that is the 0.6. 0.15 times 0.6? 0.09. While I'm here, just test you. What is that as a percent? 9%, right? Move the decimal 2 left, and it is 9%. Okay. As I promised yesterday, you have some work time. It's not an incredibly long homework, so you should be able to make good progress / get it done. Your homework, of course, is lesson 11.4 in Math Excel.